Hello everyone, welcome to Pepcoding. So in this video we are going to discuss a new question, that is we have to find out width of shadow of binary tree. So what this question is actually asking, that if a binary tree is given to us and we have a light bulb over here, then what is the width of the total shadow that is going to fall on this ground. So let's say what is going to be the format of shadow. Shadow of 80 is going to fall like this, shadow of 40 is going to fall like this, shadow of 20 is going to fall like this. Now shadow of 10, 50 and 60 are going to overlap each other because 10 is standing let's say before standing closer to the bulb, and 50 and 60 are standing in the same path of the 10. Okay, so therefore the shadow of 10, 50 and 60 are going to overlap. Shadow of 30 is going to be like this, shadow of 70 is going to be like this, shadow of 90 is going to be like this. Okay, so now what will the total length of this all these shadows? Let's say this is 1, 2, 3, 4, 5, 6 and 7. So therefore I can say that from this point to this point total length is going to be 7 units of length. Okay, so how we are going to calculate this? I can say that when I go to from a root node, when I go to or when I try to calculate the total length at the left side, that is at the left subtree. Okay, at the left subtree I use negative values, that is I go one level negative, one level. If I consider this as a level 0, this as at level 0, then this is going to be my -1 level, this is going to be my -2 level, and we can call this as a horizontal level because we are right now seeing in the horizontal directions, right? So I say that horizontal level at this particular point at 20, that is connected to the left side of my root node, that is this 20 is connected to the left side of my root node, therefore its level is going to be -1, its level is going to be -2. Similarly I can say that anything attached to right side of the root node is going to be, that is right in the right subtree, the level horizontal level is going to be +1, +2, +3. We can just see that more clearly in a Cartesian plane. If I draw a Cartesian plane like this, if I draw a Cartesian plane, we know that if we are standing at this position, if we are at this position, that is our root node is at the position 0, 0, then at the right side, that is at the right side, it is going to be positive x values, that is it is going to be positive horizontal level values 1, 2 and so on, and at this point it is going to be a negative value, right? This we can see that. And now with this we can develop a formula that to find the width, the formula can be written as, or can be said as, if from here to here, let's say from here to here at this position, the distance is x, and from this position to, let's say at this position, the distance is y, it is obviously going to be a negative value, right? So to bring negative, I have to add the distance, right? I have to find the total distance. Now I have to find the total distance from this point, this particular point, to this particular point. Then I have to add these two values, but one of the value is negative. So if I, let's say if I do like this, 4 plus -4, what is going to be the answer? The answer is going to be 0, but I don't want 0 as an answer because 0 is telling me that there is 0 distance, 0 unit of the length between these two values, but I know that there is no 0 unit of length. It is just that we are considering a Cartesian plane, that's why it is coming 0. So to make this negative value positive, what we can do? We can do this, that is we can multiply this negative value with another negative value, and we know that negative multiplied by negative is going to be a positive value. So with this we can develop the formula as, what can be the formula? the formula can be written as, if let's say this is an x distance, then x minus, let's say this was a y distance. Okay, instead of this minus y, this is going to be a y distance, y plus 1. Now what is this plus 1 signifying here? What is this plus 1 telling us? This plus 1 is telling us that, okay, now I have some values, that is some positive value from your side, some value, let's say x value from right subtree. I am having some value from left subtree, let's say it as y. So x minus y, or that is the formula we are seeing here, that is x minus y. If I do this, because y is my negative value, therefore I have to minus it. Or instead of, for now, let's consider that for now, just for now, for the sake of this one only, that how this one is coming, for that purpose, I'm just saying that let's say y is plus value, positive value. So I have to add this to get the total distance. And what I'm getting, I am getting the distance till this point, right? Now the shadow, or we can say that I am getting this value and this value, right? I am getting the total distance, that is these three dots and these three dots. Now I have to get what? I have to also find the, or I have to include the root node also, that is the shadow of the root node should be also included. Therefore I am writing plus 1. Okay, so this plus 1 is nothing but the shadow of the root node. So with this, I hope this plus, what is this plus 1 denoting, is also clear to you all. So this is going to be our formula. If we test our formula at this position, we can see that here there was minus 1 level. Okay, first minus 1, then minus 2, then minus 3. Okay, from the left side I got minus 3 as the minimum value, right? Now from the right side I have to find the maximum value, that is going to be 1, 2, 3, like 1, 2 and 3, right? And if I do like this, 3 minus 3 plus 1, this is going to return me what? 7. And we have calculated 7. Now you must be having a doubt that why we are, if I am just saying that if I can take this as a positive value at the right subtree, if I am taking positive, then why cannot I take the positive value at this side? So this is because if I discover what is actually what actually we are doing, we are going to do what? I am saying that from this root node, I'm going to determine that what is the minimum value or minimum depth that I can, or I can say from the Cartesian plane only, I'm going to see that from this root node, what is the minimum distance, or what is the minimum distance, or what is the, the minimum value that I can travel to on my left side. We know that minus 1 is greater than minus 100. So I have to find the minimum value or minimum distance on the Cartesian plane that I can travel on the left side. And I have to check the maximum distance. Actually, what this minimum is signifying, we can see that minus 1 is much closer to 0 than minus 100. But we want what? We want the minimum depth, that is minimum horizontal value. That's why we are in the terms of mathematics, we know that minus 100 is minimum, or minus 100 is smaller than minus 1. Therefore we have to reach till the lowest point in the horizontal level. Okay, till the lowest point in the horizontal level at the left side, and similarly at right side we have to reach the maximum level. So with this we can say that, our answer is going to be stored in this form. If I store it in a box, I can say that at the 0th position it is going to contain the minimum value of, or I'll write in a big, if I store values in the box, it is going to store what? It is going to store minimum value of horizontal level, and this is going to be maximum level of horizontal level. What this means? This means that how minimum I can travel to the left side and how maximum I can travel to the right side. This is what this is saying. So our answer is going to be stored in this kind of thing. Now just make this smaller. because I hope this is clear to you all. Now we are going to see what is our approach going to be. Now we are going to solve the question. Let's say this is a binary tree, 30, 40, here it is 50, 60, this is going to be 70. Okay, this consider this is our binary tree. So to do this, to do the dry run or to start traveling, we are going to maintain a stack. With the stack, it will be more clear to you all. Okay, here we are going to maintain a stack to see that how we are actually traveling in this tree. Okay, now what are we going to pass to this stack? The first thing we are going to pass is obviously the value at the value of node, that is node. The second thing we are going to pass it as this stack is, or this function is going to be the horizontal level, that at which horizontal level we are currently standing. And the third thing we are going to pass is, or third thing we are going to have, our calls, that is left call and right call to the left subtree and right subtree. Okay, now as we have discussed, I said that if I go at the left position, if I make a call to left side, then I have to use what? Negative horizontal level. I can say that I have to reduce my horizontal level. If I use my right side or right call, I have to use positive horizontal level. Okay, that is I have to increase my horizontal levels. With this, let's start traveling. Initially, I was standing at this position. Here, my horizontal level was 0. So 10 made a call to what? 10 made a call, first 10's horizontal level was 0, and it made call to its left child. Okay, its left child. So while coming to this left child, what we are doing? We are using negative value, that is -1. So when I reached to 20, I was having my horizontal level as -1. Now this also made a call to its left child. It was having what? The value will be reduced. So to call to 60 will be with what horizontal level? With -2 horizontal level. Now 60 made a call to its left child. It was none. It returned. And right child, it was also null. It also returned. Okay. So with this, both the calls, okay, both the calls for 60 are completed. Now, but before erasing this, let's store this -2, because what is this -2 signifying? What is this -2 telling us? This is telling us that it is the minimum value of the horizontal level, because right now in the whole stack we can see that the minimum value of the horizontal level is -2. So if I make a stack, or if I make a answer like this, instead of this, make an answer like this. If I create my answer like this, at this position, it was it was minimum, and it was maximum, right? So at this position we are going to store what? -2. Why -2? Because this is the lowest value I can travel to in the left side. Okay, so here I stored -2, and my max value is my value going to affect? No, it is not going to affect right now, because maximum of 0 and -2 is going to be -2 only. So here max value is going to remain same. Now after this, both the calls have been done for 60. Now what we are going to do? Now we are going to return here at 20. So when I reach to 20, horizontal level in this stack was -1, but my minimum was -2. So will my minimum update? No, because we know that minimum of -1 and -2 is going to be -2 only. Therefore it is not going to update anything. Now this 20 made a call to its right child. So while going to right child, we have discussed that while traveling to the right, we have to increase our horizontal level. So when I reach to -2, so when I reach to 40, from 20, that is while after making a right call, the horizontal level, here my horizontal level was what? -1. So while reaching to 40, what I did? minus 1 plus 1 minus 1 plus 1. So horizontal level here was 0. Okay, so with this I hope you understand that while going to right side I have to increase my horizontal level in the stack. So in the stack I am increasing my horizontal level, and while going at the left side I have to decrease my horizontal level. You can see here, while going to the left side I decrease my horizontal level. So now with this I made a call to left and right. From here null null, it returned nothing. Okay, and it returned here. Will anything change in this minimum and maximum? No, because maximum of 0 and 0 is going to be 0 only. Therefore nothing is going to be changed. Now after this, both the calls I have done for 40, both the calls have done are completed for 20 also. Now we are going to return from here to here, right? We are returning from 20 to 10. Now at 10, left call is done. Now we are at the horizontal level 0, and we made a call to right side. So now while going to right side, we increase the value, that is plus 1. So at this position, what it is going to do, at 30 it is going to have horizontal level 1, and it is going to make a call to its left. While making a call to its left, at this position, what we have to do, while going to the left side we have to reduce our value. Therefore it is going to be, sorry, not minus 1, but it is going to be 0, because in the stack, before making the left call, what was my horizontal level? My horizontal level was 1. After making the call, that is to left side, I have to reduce it. Therefore I am reducing it. So while going to 50, it is going to be 0, and this will make a call to left and right. So here none none, it is going to return. So while returning here, we can say that here in the stack, the maximum value right now, maximum value of the horizontal level is 1. So at this position I'm going to update this to where? To 1, because 0 and 1, maximum of these two is going to be 1, right? So we are going to update this. Now left call is done for 30. Now it is going to call its right side. While going to right side, it is going to go with value 2. So at 70, the horizontal level is going to be 2, and left and right will be called, that is going to be null null, and it is going to return. Now the maximum, before returning we can see that the maximum value in the stack of the horizontal level is 2. Therefore we are going to update this. So maximum value is being updated. So here it is going to be 2. Now this will wipe out of the stack. This will also wipe out, and this will also wipe out, because both the calls for 10 and 20 are done. Sorry, 10, both the calls for 10 is done. So it is going to return here, it is going to return here. So at the 10th, that is at 10 comma 0 comma, left call is done, right call is done, therefore it will return. So right now currently I am having answer in this format, that is my minimum level was stored at the 0th location, and my maximum level was stored at the first position. Now the end, what I have to do, I have to just use my formula. I have to return what? I have to return my answer as a minimum of, or let's say instead of minimum I can say that maximum minus minimum plus 1. I have to return this only. So what is this going to be? This is going to be minus 1 minus of minus 2 plus 1. This is going to be what? 5. Now let's calculate if we are getting the width as 5 or not. This is 1, 2, 3, 4 and 5. So we are getting our answer as 5. So therefore we can say that this formula is working, and we have to just keep on updating minimum. When we are encountering a minimum value of horizontal level in stack, we have to update it, and similarly we have to do it with maximum. And when we go to left side, we are reducing our horizontal level, and when we are going at the right side, we are increasing our horizontal level. So with this I hope the dry run was clear to you all. Now let's code this and see that how it is going to look in the code format. Now to code this, what we are going to do, we are going to first create our answer, that is going to be a vector format, and we'll name it as answer of size 2, and initially the values that we are going to contain are 0. Right, now we are going to call this function, that is width calculator. And what we are going to pass to this width calculator, first we are going to pass our answer vector. Now we are going to pass horizontal level. So tell me what will be the initial horizontal vector or horizontal level for this. Initially my horizontal level was what, 0, so I am going to pass 0. Now next thing I have to pass is root node, so I am passing root node. Now after passing root node, what we are going to return from here, we are going to return our answer, that is at the 0th position, or at the 0th or at the first. We are going to say that at the first position minus answer at 0th position plus 1. Why we are doing this? Because we are storing the negative value, or let's say the answer coming from the left subtree at the 0th position, that is going to be obviously my negative value. And at the right subtree, at the first position, we are going to store the answer that is coming from right subtree, that is going to be a positive value. So therefore we are doing this. Okay, now what is going to be what we are going to write in this thing, we know two things. First, that we have to make calls. Okay, so we are going to make call to left subtree and right subtree. So we are going to use this with calculator. We made a call to left subtree with answer as it is. And now what we are, if let's say I'll just first make a call to left, and similarly I'm going to make a call to right. Now what for the left call, what will be the horizontal level, that how we are going to pass the horizontal level. We have already discussed here that when we are going to use the left call, we are going to reduce my horizontal level. So I am just doing that. I'll be reducing my horizontal level by 1, and similarly when I'm making call to right side, I'm going to increase my horizontal level by 1. Right, I hope this was clear to you all. Now after making this call, what we have to do, we have to store our answer, or we have to update our answer. So I'm going to update this at the 0th position. What we are going to store, we are going to store minimum of answer at 0, and the horizontal level that I am getting in the stack. Right, and similarly at the first, I am going to store max. Right, now what will be the base case? We know the base case, it is going to be if root is equal to null, do what, just return from there. Right, this is going to be our code. So you can see that code was really easy. What we did in this code, we did nothing, but just at the every step we checked to how to, if we are going to update any value in our horizontal, in our answer vector, that is if we are finding any minimum value or any new maximum value, we are just going to update, and finally we are going to just have it stored in our answer vector, and in the main function, that is in the width function, we are going to return the answer using our formula. Now let's try to run this and see if it is submitting or not, or it is giving us a correct output or not. So it is getting successful. So let's try to submit this, and all the test cases are passing. So with this, I hope the question was clear to you all. So thank you for this video. Let's meet in the next video.